Okay, so we've got a person walking 2 miles to the west, and then she's going to walk 3 miles perfectly southwest. So if you think of a compass, north, south, east, west, she's going perfectly south and to the west at a 45-degree angle, so right in the middle of south and west. And so they want to know how far away from home is she. They want to know this length there. So if I kind of pull out that diagram, take out that compass to make it a bit more interesting or legible, 2 miles this way. If that angle there is 45 degrees, then this is 180 minus 45 is 135 in there. And then this is x there. And we know, let's see, and she walked 3 miles that way. So yeah, so we've got a side angle side case, the included angle of the two sides. So that means we're using law cosines. So it's the side opposite of the angle squared is the other two legs squared. So it starts off just like Pythagorean theorem, but then minus 2 times those sides multiplied together times the cosine of that guy there. And I usually just plug it in on my calculator all at once. I just take a square root of both sides, and I'm literally going to type in now the square root of 2 squared plus 3 squared minus 2 times 3 times the cosine of 135, and I'm making sure I'm in degree mode, and I'm getting 4.63522. And so that's how far she is from home. And then here she is. They want to know in what direction must she travel to get back home. So I kind of want to know a couple angles. I kind of want to know this angle. Hold on. Because the direction, here she is, she's got to get back here. So traveling in that direction. So I kind of want to know what that is. And since this and this, those lines I can draw as parallel, then they're going to be the same. So if I can find that angle, I'll know that angle. Is that what I want to know? What direction she has to walk? Yeah, that's what direction must she walk? Okay, so no matter what we need, we're going to need to find another angle. Once you use law of sines, cosines once, you can always go to law of sines now. So if I am going to look for this angle here, I can say that the sine of that angle over the opposite side, the 3, equals the sine of the 135 degrees over its opposite side, which is that ugly mess that we just got. And so if we do our cross multiplying, we're going to get that the sine of our angle equals 3 times the sine of 135, then divided by that icky mess. And so on my calculator, 3 times the sine of 135 divided by 4.63522 is 0.457. And so now to undo the sign, I'm going to do the inverse sign. So second sign of second answer is going to give me that the angle is 27.23. So to describe that that direction, if this is 27.23 degrees, she's going 27.23 degrees north of east. You could say north of east. And that would be one way to describe the direction she's going. So she's not going directly east, she's going 27.23 degrees north of east. Yeah, there you go. Okay, so the thing about this one is that pitcher's rubber isn't directly in the center. That would be too easy, right? So I want to find the distance from the pitcher's rubber to second base first. And I'm going to do that using this whole big triangle here. Let's get it in a pretty color. This right triangle there. Because if I can find this length, I'm just going to take away the 60.5 to get that. So I know that this is 90, this is 90. So if you remember your 90, 90, 90 root 2, your 45, 45, 90 triangles S, S, S root 2, you can get 90 root 2 pretty darn quick. If you don't, you take it over to the side, do a squared plus b squared equals c squared. That'll also get you 90 root 2. So that means that the pitchers to second base is the full 90 root 2 minus the 60.5, whatever that is. So, and then now we need to find pitchers to first. So let me draw another triangle for that. Let me get rid of this triangle maybe. So now we want pitchers to first base. So we're going to be looking at that triangle. It is not a right triangle because that pitcher's guy is not quite in the center, so careful. And then I should get a decimal for this because that is that length that we're going to need there. So 90 root 2 minus 60.5 is 66.779. So this is 66.779. And then this is what we're trying to find now. And what else do we know? Okay, so you've got a side, side, side case. So side, 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 we're thinking law of cosines again. And so we can say, oh, I need an angle, right? Never mind. All right, so pitchers to first is what we need to find. I want to use this triangle here to get an angle because even though he's not standing in the center this way, he is standing in the center this way. So this is 45 and 45. So that's a 45-degree angle right in there. So that's 45. And then this distance they told us was 60.5. And this is 90. So now we're going to use law of cosines again because we've got a side angle side case to say that the x squared equals the 60.5 squared plus the 90 squared minus 2 times the cosine, 2 times 60.5 times 90 times the cosine of 45 degrees. I'm going to take this, going to put a big square root on it and punch it in on my calculator all at once. So square root 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45, and that's 63.71. So, and that's to first base. So pitcher to second was 66.79, pitcher to first was that, so it looks like it's a little bit closer to throw to first base, and then you can just subtract and find by how much. Whew. All right, let's see what they got for the second one. So now, sorry, the ball is going to be hit from home plate to a point 30 feet past that. An outfield comes in to catch the ball. How far is the throw from home plate? How far is the home plate to third base? So you're looking for all of this here. Well, didn't we already find that? Because we found the full distance across was the 90 root 2, right? So it was 90 root 2 plus 30 is to home. So this we found in the first part, and then adding the 30. And then now they want the throw to third base, so now they want that length there. And we can use this big triangle. Let's see. Yeah. We can do this one because we know again that this is 45 degrees in there because the picture is right in the middle this way, so that is split. And the 90 root 2 plus 30, I'll punch that in so we can work with it. So that's 157.27. That's this 157.27, and then this they told us was 90, and then we're law cosines again. So the x squared across from the angle that we're working with is the 90 squared plus the 157.27 squared minus 2 times 90 times 157.27 times the cosine of that 45 degrees. So again, you're just going to punch this all in on your calculator with underneath a big square root, and you'll get something for your x. I trust you. Cool. And I think that's that one. Awesome. Okay, so I'm just going to draw a random triangle. I'm going to draw A, B, C. I'm going to label B as 22 degrees. A is across from big A, 18.7, and then C is across from C, 21.0. And if we want to solve this, we've got a side angle side case, the angles between the two sides. So this one's super nice. This is just law of cosines. Every time you see side, 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 or side angle side, it's law of cosines. So this B guy across from B, so the side across from the angle that you're looking for goes on its own, and then it equals, starts off like Pythagorean theorem, 18.7 squared plus 21 squared, but then because it's not a right triangle, you minus double the legs multiplied together and then times the cosine of the angle in between. And then just take a big square root of both sides to get the b, and you're going to put this in on your calculator all at once. So big square root, 18.7 squared plus 21 squared minus 2 times 18.7 times 21 times the cosine of 22, and you get 7.9044. Just make sure you're in degree mode. And I didn't read the directions. Do they want me to solve for the whole triangle? Let me check. Yep, they want us to find everything. So we've got all the sides now. And then once we use law of cosines once, you never have to use it again. You can just go back to law of sines. So I'll do maybe the sine of A over its opposite side, the 18.7, equals the sine of B, that 22 degrees, over its opposite side that we just found. And then you do your cross multiplying. You multiply on the angle that you can and divide by the other guy. So the sine of A will be 18.7 times the sine of 22, and then divide that by 7.9044. So the sine of A is 0.886233, and then you undo the sine by taking the inverse. So second sine, second answer on your calculator, and you get that A is 62.4 degrees. And then the last angle, you can always just find if this is 62.4, then C is just 180 minus the other two guys. So 180 minus 62.4 minus 22, and you'll get something. Cool. Okay, so I drew my just generic triangle. I like to draw, if there's only one angle given, I like to draw it down in the corner there, just because that's the way I like to see my triangles. I have trouble turning them in my head. So I put the C down here, and then across from it was the 259, and then the B I put over there, so across from it was the 510, and then the A's up there. And so we do notice we have the dreaded donkey case, the angle side side, where the angle's not between the two sides, it's angle, then side, then side. So this is the, be careful, this is the ambiguous case. So maybe there'll be no solution, that would be nice. Maybe there are two solutions, that would be not nice, so nice. Or maybe there's just one solution. We will find out. So you just proceed as normal with your law of sines. So we'll do the sine of the angle over its opposite side equals the sine of the angle over its opposite side. And then you'll solve for sine of b like normal, so you'll multiply by the diagonal you can and divide by the other guy. So I'm just going to do 510 sine 30 divided by 259, and that'll be 0.98455. And then you just do the inverse sine of that, and you get that b is 79.917. And so our calculator didn't yell at us and give us a domain error, which would have happened if this sign had been bigger than 1, like if it had been like 1.02 or something like that. That's not possible. So that would have been the no solution case. So it's not a no solution, but there is a possibility that it could be two solutions. So your calculator told you one angle where the sine equaled 0.98, but you know that there are two quadrants, right, where the sine is positive. So sine is, the y value is positive in the first quadrant and in the second quadrant. So you always have to check, well, maybe 180 minus that works. So it's always 180 minus whatever angle your calculator gave you. So I'm going to see if, because that's another possibility. So we get 100.08. And so we look and see if that's a possibility for B. So 100.08, is there enough room for this other angle? And darn it anyway, there is, right? That's only 130 degrees so far. I've got some room left. Sometimes this angle is so big it doesn't fit in the triangle. Sometimes that angle is like, 170, and you're like, wait a second, 170 plus 30, that's 200 degrees. That's not going to make a triangle. It's just going to be this one case, and you just finish out this one case. But darn it anyway, for us, this 100, I'll call it 100.1 degrees, does work. So what I'm going to have to do is draw a second triangle, and I'll draw them over here. And you don't have to draw them to scale, but what's happening is instead of, so one of my solutions will have the 79.9 degrees in it for B. And then this side here could have swung over here to make this other triangle, which is what I drew here, where this angle is 100.1 for my B. And everything else stays the same, right? The C is still the 30 degrees, across from it is the 259, and this is 510. And now you have two separate triangles that you have to finish solving with law signs. Yay us. So either this one or that one. So I will finish solving the first one first. So all I need to find, I can easily find my last angle. I don't know if a different color will help or hurt, but we're going to do it. So how about a nice soothing blue? I'll finish finding my last angle by just doing 180 minus 30 minus 79.9 because there are 180 degrees in a triangle. 70.1. So this is 70.1. And if that's the case, I can finish finding my last side, that A, by doing law sines. So the sine of the 70.1 over A will give you the sine of, I'll use the 30 over its opposite side. And so then to solve for A, you just multiply on the diagonal you can and divide by the other guy. So it'll be 259 sine 70.1 divided by the sine of 30. And so your A will be 487, about 0.1. It's, oh, if you need more, it's 0.069. So coming back up, your A will be 487.069. So now we have all the angles and all the sides for that triangle. That triangle is solved. Check. And then you just go and finish this second triangle. So if the B was 101, 100.1, then the A would be just 180 minus 30 minus 100.1, just from 180 degrees in a triangle, nothing fancy there. We get 49.9. So that's 49.9 in there. And then you could find side A by doing law sines. The sine of A over its opposite side equals the sine of 100.1 over its opposite side. And so we'll do multiply on that diagonal and divide by the other guy. So we'll do 510 times the sine of 49.9, and we'll divide that by the sine of 100.1, and so A is 396.3ish. Check. And so that would be the last, 396.3 would be the last side of that. And so you got all the angles, all the sides of the second guy. Woohoo!